This is a quick video to cover some key concepts out of Section 3-1, Measures of Central Tendency. We're going to hit three high-level things here. First off, I call out the general rounding rule there, and you'll see it detailed on page 119 in the book. When you're calculating a mean or a standard deviation, what you typically want to do is go one decimal place beyond whatever your data is. So what that means, if your data is whole numbers, then your mean or standard deviation should have one decimal place. If your data had one decimal place, like GPAs, you had 3.7, 2.9, 3.4, and you took a mean of those, you would want two decimal places. So general rounding rule, mean and standard deviation, one decimal place more than whatever your data is. Now, these next two definitions I want to call your attention to. You need to pay attention to the definitions themselves. They are significant, but more significant is something with the notation that goes along with them. Okay, and the two definitions are the idea of a parameter and a statistic. And they're very similar. A parameter is a characteristic or measure obtained by using all the data values from a specific population. The statistic, same thing. Statistic is a characteristic or measure obtained by using sample values. So the parameter, you're selecting from all items that share whatever characteristic you're looking at. So if you were looking at calculating something against U.S. senators and you used all 100 U.S. senators, that would be a parameter you had calculated. If you calculate something against a sample, so you've selected a sample of the values, not every value that meets the criteria, then you've calculated a statistic. Okay, so those definitions are moderately important. But the thing you want to pay attention to that'll help you in this class is that typically in this class, when you see a parameter, the notation for it will be a Greek letter. When you see a statistic, the notation will be a standard English letter. Okay, and you'll see, like later when we get to the standard deviation formulas, there's a lot of carryover where most of the difference is you have a Greek letter in one case, English letter in the other. All right. Now, last thing on this short video is to talk about the averages. And in this course, we talk about 4 different averages. It's really kind of 3 averages and 1 weak cousin. So, first average is the mean. You'll also hear it referred to as the arithmetic average. And you'll see there in parentheses the notation for that is the Greek letter mu, which is that U with the long tail, or you'll see X with a bar over it, X over bar. Now this is the average that most people think of when you say the word average. To calculate, you take all the values in your data set, add them up. Once you have that, divide by the number of values. That's all this notation here means. You see this sigma, the numerator, you see the capital sigma, Greek letter sigma. When you see that in this class, that says we're adding something up. So we're adding up all the values. X is each individual value. And then N is the number of values. So add up all your values, divide by the number of values. For those of you that are trying to learn a little bit more about Excel, this would be the average function in Excel. There is no mean function. To me, there probably should be, and I would be fine if average routed the same place, but it would be nice if they also had a mean function. All right, second average, and it's one that most people have heard of and at least have kind of a fuzzy understanding of, if not a good understanding, is the idea of the median. And now the notation for this, you'll see there is the Greek letter eta, which looks like an N, or MD. For whatever reason, you rarely see those. I had to look up what the eta value actually was because I've seen it so seldom. Now, what the median is the middle value of the data. Now, if you have an odd number of values, that works great. You keep moving to the middle. When you get to the middle, there is a single value. So if you have 9 values, you have the 5th value would be the median. There'd be 4 lower, 4 higher. You're left with the one in the middle, the 5th value. That's your median. On the other hand, if you have an even number of values, you need to work your way to the two middle values and add those two together and divide by 2. Now, one thing I didn't mention here, when you're doing this, you need to make sure you put your values in order from lowest to highest. So don't just take your unsorted data and attempt to do this. That won't give you a meaningful number. You need to have your data sorted in ascending order. But backing up a little bit, when you have an even number of values, so for instance, say we had 10 values, as you'll see in example 1, you need to work to the middle, and what you would see is your 5th and 6th value are in the middle. 5 and 6, you have 4 lower, 4 higher. So those two values are in the middle. So you take your value for number 5, 5th position, your value from the 6th position, add them together, divide by 2, that is your median. Now, people say, okay, why would I need the median? The reason for that is the median has one big advantage over the mean. The median value is what is known as a resistant statistic. The mean is not. Now, what do we mean by a resistant statistic? The example I use for this is if we took our class, there are 19 students in the class, so if we took the 20 of us and if we were physically meeting somewhere and we took and calculated the mean of our salaries, that would probably be a somewhat meaningful number. Now, if on the other hand, we had the 20 of us together and Bill Gates or Warren Buffett was in as a guest speaker, and we now took the mean of the 21 of us salaries, you know, the billionaire in the room would drive our mean way, way higher than what at least I, and I expect the rest of you's, salary would bear any resemblance to. So the mean is not a resistance statistic because that one outlying value manipulates the mean pretty radically. On the other hand, the median would not be nearly as dramatically affected. If we were calculating the median with the 20 of us, we'd grab the 10th person, the 11th person out of the order, and we would add the two together, divide by 0.5. We throw Warren Buffett or Bill Gates on the top of that. We now have 21 values. We pick the 11th value. We've made very small change in the median versus what we had done to the mean. It has no more effect than if they made $1 more than whoever the highest earning person in the room was before that. So that's why the median is a resistance statistic, and that's why you will see it in use in many cases. You'll typically see it with things like income. You'll hear the news media, median family income for a county, or median family income for a city or a state. All right, then the third major average is the mode. And the mode is the most common value in the data. Now, there are a couple of unique things about the mode. Number one, it works for categorical data too. So you can look at a set of data and just say, what is the most common value in this data? If we go back to the example with the motorcycles from chapter 2, when we look at that, Harley Davidson had the highest frequency of any class. Harley Davidson was the mode of that data set. We can't calculate a mean, we can't calculate a median on that data set, but we can figure out a mode. Okay, the other thing is, there is not always exactly one mode. If your most common frequency, if there's a tie, you can have all of those values be the mode. So you could have 2 or 3 or maybe even 4 modes, depending on your data. The flip side of that is, if all of your items are unique, if they occur exactly once, there is no mode. And now be careful with that. You don't want to say the mode is 0. You could have that where the most common value is in fact 0, but that's a different thing. If all items are unique, you have no mode. Okay, now I had forgotten to mention the Excel function for median was median. The Excel function for mode is mode. Be very careful with this. It does not do well in those two special cases I just mentioned, where every item is unique and where you have multiple modes. Typically with the multiple modes, it will show you one of them, but it won't notify you that there's more than one. And then the final average is kind of the weak cousin of them, and that is the mid-range. The mid-range is you take the lowest value in the data plus the highest value, divide by 2. Now, the big saving grace of this is it's easy to calculate. You can grab two quick numbers, add them together, divide by 2, you're done. Now, the bad news, it is not a resistance statistic. You're taking the extreme low value, the extreme high value. Either one of those or both of those values may bear no resemblance to the majority of your values. So that's a bad thing. In real life, I have seen one case where the mid-range is used, and that case is in weather forecasting. If you look at the average temperature for a period, this is how they calculate it. They look at the average temperature for yesterday. What they do is take the low temperature yesterday plus the high temperature yesterday divided by 2. And that's the average temperature that they will list for yesterday.